Hi Year 10. Instead of just doing a paper-based copy of the answers today, I just thought it was as quick and easy to make a video whilst I was working out the answers. So I'm talking you through my thought process and then you can mark using the video instead. You might find that a couple of the earlier questions are actually quite straightforward and you're confident that you've got those ones right. So in the description below, I've done some timestamps where you can jump to any of the 7 questions. If there's a question that you've particularly struggled with, again, just use those timestamps to jump to that question. So, question 1 talks about 2 squares. We can immediately interpret from that or deduce from that that because these are squares, we have some parallel sides. So we know that some of these vectors will be equivalent. So for the first one, it says find bx. Bx goes in the same direction as ay. It is parallel to ay. It is the opposite sides of the square. So those two vectors are the same. So the answer to that one is just q. Ax. Okay. Planning my route from a to x, I'm going from a to b and then from b to x. So that is p plus q. A to d. Well, again, we've got 2 identical squares. So if that's q, that is another q all the way across to q. And finally, a to c is across this diagonal. I could either go this way or I could go this way. And it doesn't matter which way I go, it will be a Q, and a P. So it will be P plus 2 Qs. Moving on to question 2, we have a trapezium. So we know that 2 sides of a trapezium are parallel. And we are told it here that PS is twice the length of QR. So let's see what we can figure out. We are told that that is A and that is B. And I'm already going to write it on my diagram, that this one here, if this is B and it's twice as long in this direction, this must be 2B. So the first thing we're asked to do is Q to P. Now notice we already have P to Q defined, so Q to P is just the opposite of this. So it is a negative A. P to R is across here. The route that I would take would be P to Q and then Q to R. So that is an A plus a B. Following on, we now have P to S. Well, P to S I've already written on. P to S is just equal to 2 B's. And then finally Q to S. Plan your route. So I think Q to P, then P to S, so that is a negative A plus 2 B's. Okay, let's take a look at question 3. Things are starting to get a little bit more interesting now. The diagram shows a triangle, ABC. AP is a third of AB. AQ is a third of AC. Okay, this certainly is not drawn accurately. And AP is P and AQ is Q. And then we've got lots of little vectors to find in a moment. Well, I'm just going to add some additional information to my diagram because it says that AP is a third of this line. So if that's a third of it from there to there, then all of this must be 3 times that. Certainly doesn't look 3 times, it looks nearer 2 times, but that is because it's not drawn accurately. So I'm going to draw this little bit in here as an extra 2p. And similarly this side, because we know A to Q is a third of all of this, then all of this must be 3q, so I'm just going to drop in a little 2q there for later. Okay, it now says find in terms of P and Q expressions for P to Q. So P to Q, always about planning your route. P to Q is P to A and then A to Q. So for this one, I'm going to go along this path negative p plus q. So that is negative p plus q. A to B, well, we've already kind of discussed that. That is going to be 3 p's. A to C, again, we've already discussed that because that is going to be 3 q's. Now then, B to C. Again, plan your pathway. I'm going to go from B to A and then A to C. That is equivalent to going from B to C. So minus 3 p's plus 3 q's. And it says, hence, use your results from A to prove that PQ, this one here, is parallel to BC. Well, remember, to prove something's parallel, we just need to argue that it is a multiple. And we can clearly see that this one is 3 times bigger than this one. So I could say that B to C is 3 lots of P to Q. Okay, that is me showing that one is a multiple of the other. And I will then just spell it out really explicitly. Since multiples, they must be parallel. So question 4 is a little bit different because in this question we are given some coordinates, okay, and we're asked to work out some column vectors. Now you could technically draw a diagram for this, but there is no need if you think about it carefully. When I'm going to be working out my column vectors, I'm just going to be comparing the x components and the y components of the coordinates and using those to generate the vector. So for example, if I'm working out vector A to B, I can look at the x component 1, look at the x component of B and see that it is increased by 4. So it must be 4, and now comparing the y component, 1 to 8 is 7. Looking at DC, D to C, make sure we're doing the right order. The x component is 7 to 11, so that's 4. And 4 to 11 is 7. So because these two vectors are identical, it says, what do these answers tell you about A, B, and DC? Well, they are parallel and the same length. Write column vectors for B, C, and AD. Well, let's do the same. B to C, 5 to 11 is an increase of 6. 8 to 11 is an increase of 3. And then going from A to D, 1 to 7 is an increase of 6. And 1 to 4 is an increase of 3. So these two vectors are also identical. So they are parallel and the same length. But one thing to notice is these are not the same as each other. These are not the same length. You could even do some work if you are interested by looking at the magnitude. But these are not the same length as each other. So there's only one shape that has parallel sides that are not the same length as each other. And because of these numbers, I know also they're not at right angles. So the shape that we're after there is a parallelogram. Okay, question 5 tells us we have a parallelogram. Now that means we can make assumptions because we know that parallelograms have parallel sides. So for example, if I've had that vector defined as A from P to Q, I can already make the assumption that S to R is also A, and similarly Q to R in that direction is the same as B. So using the fact that it's a parallelogram, I'm just going to write those already onto my diagram. And now let's see if we can do some questions. We're also told that E is the midpoint of QS. So Q to S. I'll do that one up here. Plan your route. And what I mean by plan your route, I've been verbalising the route as I've been doing this, but really it's a good idea to write it down that you're going from Q to P and then from P to S. So that's what I mean about planning your route. Q to P is negative A and P to S is positive B. So that's part 1 done. Part 2 is asking for Q to E. Well, we have just worked out Q to S, and we know that E is the midpoint. So what I can do for Q to E is just do half of Q to S. And half of that is negative a half A, and half of that is plus half of B. Finally, we're asked to do PE. And PE is across from there to there. So plan your route from P to E. Well, we can go from P to Q and then Q to E. Why am I going that way? Well, because I've already defined those vectors that I can use. So I'm going to do P to E as P to Q and then from Q to E. So it's this one plus an extra A. So what happens when I plus an extra A to that negative a half A? It's going to become positive a half A plus a half of B. It then goes on to say explain why SR is A. And I think I've already explained that. It's because of properties of a parallelogram having parallel sides of the same length. It then says find PR in terms of A and B. So PR is just along here, so it's a B plus an A. So that answer there is just an A plus a B. It then says what can you deduce, what can you figure out about the diagonals of a parallelogram. Now this might be a property that you already know, but if you look at that one, which was P to E, and if you look at that one, which was P to R, you will see it's that one chopped in half. So the diagonals of a parallelogram bisect each other, they chop each other in half. And that's true for any parallelogram. So they bisect each other. So remember, bisect, just a posh word for chop in half. You've met that word when you've done some work on constructions. Okay, question 6 is similar to a question we've seen previously because there's no diagram. So we are going to be looking at the coordinates and trying to figure out, if we can, what these column vectors are. So A to B, this time we are going from -3 to 9, and -3 to 9 is 12, comparing the x numbers, and -3 to 3 is moving 6. Now we're doing from D to C, and D to C is -1 to 3, so that is 4. And we've got 5 to 7, and that is 2. Okay, it then says, what do your answers about part A tell you about AB and DC? Well, if you notice, they are actually multiples of each other. If you times this one by 3, you get this one. So they're not the same length, but they are parallel. What type of quadrilateral is this? Well, there's only one type of quadrilateral that has parallel sides of different lengths, and that is a trapezium. Okay, so the final question looks a little bit more interesting, so let's see how we can get on with this one. Let's have a quick read. It says the diagram shows a quadrilateral, PQRS. We have various vectors defined. PQ is 2A, PS is 2B, SR is 2C. We have all of these are midpoints. And it says explain why QR is this vector here. Well, if I was going from Q to R, I could go round this way. So QR is Q to P, then P to S, and then S to R. And these are all the vectors that have already been defined for me. So it's negative 2A plus 2B plus 2C. Now it says find E to H in terms of A, B and C. So E to H. So let's plan our route from E to H, perhaps using some vectors we've already calculated. So E to H, it's a funny looking H. E to H could be E to Q, and then Q to H. And we already know E to Q must be half of this, which is A. And we already know that Q to H must be half of what we've just worked out as QR. So I'm just going to halve all of this. So it's negative A plus B plus C. And what you'll notice there is your positive A and your negative A cancel. And I just end up with B plus C. Now it asks us to find F to G in terms of A, B, C. Okay, and I think for the F to G, I'm just going to do this route here, which is a B plus a C. So F to G is also B plus C. So that was a B and that was a plus C. So what can I deduce about these line segments? Well, we've had this before. They are parallel because they are identical and the same length. So those are the same length. Okay, what type of quadrilateral is it? Well, for the same reason as what we've done before, it must be a parallelogram. Parallel lines the same length. We don't know that these are at 90 degrees, so we can't deduce it's a rectangle, so it is a parallelogram. So I hope this has helped out. If you've got any further questions, don't hesitate to get in touch, please.